Not even close. Okay, so we're going to start with rectangle. Make sure everybody's on the same page. You should have watched the video, so you should be able to answer the following question, which Will has been kind enough to volunteer for. Tell me what you know about that rectangle, Will.
The diagonals bisect at A.
They bisect each other?
Yeah, and then
Okay, good.
the each side is parallel and congruent to each other.
Okay, so this is parallel to this, that's congruent to that. This is parallel to this, that's congruent to this. It's a good start. What else you got?
Oh, each corner is a 90-degree angle.
Good. Good, what else?
The angles are supplementary.
Could you be more specific?
Oh, like EC and RT.
Adjacent angles or something, ignoring the angles that are formed by the diagonals. Okay, good, what else? Emmett?
The opposite angles are congruent.
Opposite angles are, yeah, they're all 90 degrees, good. Violet?
The bisecting, the diagonal lines are congruent.
Good. So if the diagonals are congruent and they bisect each other, that means that this is equal to this, is equal to this, is equal to that. Good? What else? Good.
Triangles are congruent.
Be more specific. There's a lot of triangles up there.
RAT and EAC.
Good. Okay, so this triangle is congruent to that triangle. This triangle is congruent to that triangle. Any other triangles?
The big ones.
Yeah.
RCT and EPC.
In fact, all four of those triangles are congruent, right? So RTC is congruent to REC is congruent to RET is congruent to ECT. Good. What else? Go ahead.
I have a question, actually.
Certainly. What'd you call me?
I said I have a question, actually.
Oh, I thought you called me Ashley.
No.
That's not my name. Besides, that's Mr. Ashley to you. Go ahead.
What theorem or property makes the two triangles there congruent and the two triangles there congruent?
Good question. You could use side angle side. Since we know these puppies are congruent to these puppies and you got the vertical angles. You could do side, side, side. You could do side, angle, side, a whole bunch of different possibilities. Okay, what we don't have and what we didn't talk about yet is, what's the definition of a rectangle? What makes a rectangle, Evan?
It's a parallelogram.
Beautiful. Let's write it in if-then form. If a quadrilateral is a rectangle, comma, then it is a parallelogram with what?
4 right angles.
Beautiful. 4 right angles. We're going to use that for our definition. Now, because it's a parallelogram, everything that applies to a parallelogram also applies to a rectangle. Are you with me on that? Okay. Golden retrievers are dogs. So anything that applies to a dog has to apply to a golden retriever. Right? Okay, good. Everything else that you told me comes from the properties of a rectangle. Of those things that were listed, Gesundheit, what's true about rectangles that's not true about parallelograms? So we already have the right angles. Parallelograms don't necessarily have 4 right angles. What else up there is true for rectangles but not for parallelograms? Emma?
The diagonals are congruent.
Good. Anything else?
the triangles are congruent.
Yeah, that whole business with the triangles. Remember, in a parallelogram, we still had these triangles congruent, but not all those big triangles congruent. So those are the big things. Number one, the diagonals are congruent. Number two are the right angles. Everything else falls into place. So we're going to start talking about something called a hierarchy today, which means how do things fit together. Okay, what's the most general term and how do we get more specific? So our most general term is going to be a quadrilateral, and then we're going to go from a quadrilateral to a parallelogram and start branching things out. We'll work on that later. The difficult thing for you as we cover more and more shapes, like today we're going to do rhombuses and squares, is that more material starts to be true of figures that aren't necessarily true for other figures. I don't know if that statement made any sense. Okay, we also are going to deal a lot with the whole golden retriever dog thing again. Okay, so all rectangles, all rectangles are parallelograms, but not all parallelograms are rectangles. You with me? Do we need to talk about this anymore? Okay, good. Let's move on then. Let's start with a rhombus. For some reason, the color changed. All right, we need two things. We need a definition and we need some properties. Properties. If a quad is a rhombus, comma, then what? Here we go. Go ahead.
The four sides are congruent.
Excellent, but we need one little other chunk of information. So are you saying that any quadrilateral with four equal sides is a rhombus?
And parallel.
We could go that route, but if the sides are parallel, it's also a parallelogram, right? Good. Okay, then it is a parallelogram with four congruent sides. Well done, Dev. Boom, 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 boom. As far as properties go, we want to list all the things that are true about the rhombus. Property number one, which we should have listed for rectangles, is the following. All properties of parallelograms apply. Okay, so we don't have to talk about the opposite sides being parallel, the opposite angles being congruent, the opposite sides being congruent, the diagonals bisecting each other. What we're looking for step two then is what's special about a rhombus? What's true about that figure that's not true about all parallelograms? Any guesses? Go ahead.
The opposite angles are congruent.
Be more specific.
So RO is congruent. No, angle MRH is congruent to MOH.
That is true, but that's also true in a parallelogram. Too bad.
You can see the isosceles triangle on like both sides. So like the angle,
Be specific.
like the MOR is congruent to like HOR.
That's also true, but also true in a parallelogram. But they're not isosceles in a parallelogram. So we could throw that in there. So how would we say that?
I don't know.
Okay. Becca?
The diagonals are perpendicular to each other.
Beautiful. Diagonals are perpendicular. Whoosh. What else? I guess I should ask two questions. What else, or is there anything else?
Maybe.
Maybe. Good. That's a good safe answer, coward. Diagonals bisect each other. Are the diagonals congruent?
No,
Yeah.
maybe.
Somebody's going to get a punch. What's that? Who's talking? Nobody.
Never
Great.
mind.
I'm hearing things. Michelle, are you talking?
I said never mind, I gave up because I was
Okay.
going to say something.
I
Alright.
think they are.
You think they're what?
Yeah. Congruent.
So you think that RO is congruent to MH?
No.
No.
I think that B is the midpoint of all of them. Then they're equal. Never mind. I think RB is congruent to BO.
She said BO. That is true. But that's also true with parallelograms.
I think that RO and MH are congruent.
You think that RO and MH are congruent?
Yeah.
No, they're not. Because if we draw an extreme rhombus,
Oh, yeah.
we could have something like that would make a rhombus also, if my pen would work. Big stretched out diamond looking thing. Okay, anything else? There are some things that I don't know if we necessarily need to list as properties, like for instance, RBM is a right angle, is a right triangle. Notice, well, here's something else. I did just come up with number 3. Tell me about those 4 triangles in there. Well,
They're all congruent.
they are all congruent. Diagonals form 4 congruent triangles. Okay, because this is congruent to this, and this is congruent to this, and you got the right angles, so we got side angle side. Everything is peachy. Okay, what about, oh, there is something else. What appears to be the relationship between angle MRB, monkey, rat, badger, and badger, rat, hippopotamus? Emmett.
Are they complementary?
They are not. Well, no, they're not. Not in this shape. They're equal to each other. Why? How do you know that?
Like side angle side, because they're going to be triangles.
Good. We proved the triangles were congruent in step 3, so therefore we know that this angle is equal to that angle. This angle is equal to this angle. And notice if I mark this correctly, we have that. So the diagonals bisect vertex angles. Question?
If OB, MB, OB, and HB are all equal, then how come all O and MH aren't equal?
They're not all equal. Notice I got 2 marks on these guys, 3 marks on those guys. Sorry, that one was hidden. If they were all equal, then yeah, then they would be congruent. Okay, anything else? Good, we're solid. There's a rhombus. A rhombus is a parallelogram, right? Is a rhombus a rectangle?
No.
No?
Well, it
No, it's
Uh-oh.
it's not.
Now we've got to get into the dreaded always, sometimes, never.
never.
Wait, no, it could.
Let's start with some basic questions. Is a rhombus a parallelogram? Always, sometimes, or never? Always. Is a is a parallelogram a rhombus? Sometimes. Is a rectangle a parallelogram? Always. Is a rectangle a rhombus?
Never.
Never? Sometimes?
Sometimes.
Always?
Never.
Never. Sometimes?
Never.
Oh, always?
Never. Sometimes.
Always.
Always. You're just throwing out things. Okay, good. Let me ask a question again. I forgot what I asked. Is a rhombus a rectangle?
Yes.
He's asking if a rectangle was a rhombus.
So if it's sometimes, which it is by the way, when would a rhombus be a rectangle? Paul?
When it's a square.
Oh, there you go, using words I don't know. Hold on.
What's a square?
Great question. I was just going to ask that. What's a square?
Wait, so which one is sometimes the other one for rhombus and rectangle?
Say again?
Which one is sometimes the other one for rhombus and rectangle?
We didn't cover that yet. We got to talk about this guy first. Because once we know this, then we can answer your question about that business. Okay, need a definition. And we need some properties. If a quadrilateral is a square, comma, then what? What makes that puppy a square?
Would it be that it has 4 equal sides and 4 right angles?
Love it. Then it has 4 congruent sides, which means it's what?
Parallelogram.
Which means it's what?
Rhombus.
Rhombus. And 4 right angles, which means it's a rectangle. Is a rhombus a rectangle? Sometimes. When is a rhombus a rectangle? When it's a square. Good. Properties. Well, it's parallelogram, so all properties of parallelograms apply. Okay. What else? We can do this the hard way or we can do it the easy way.
All
Ashley, what do
4
you got?
sides are congruent.
Got that?
Oh.
You are right. Let me mark that. Boom, 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 boom. Okay, what else? Go ahead.
Can you just say that all the properties of a rhombus and a rectangle apply?
Beautiful. That's the easy way to do it. All the properties of a rhombus apply. And number 3, all the properties of a rectangle apply. 4 right angles, opposite sides are parallel, opposite sides are congruent. All 4 sides are congruent. The diagonals perpendicular to each other. The diagonals bisect each other, so they're perpendicular bisectors of each other. The diagonals bisect the vertex angles. And in fact, how big are all these angles?
90.
No, how big are all those angles?
45.
45, good, because they're bisected by the diagonals. Diagonals are congruent, they're perpendicular. All that other stuff is covered. Is there anything that's true about that puppy that's not covered in these 3 statements? Are we good? Okay. Excellent. Is a square a parallelogram?
Yeah.
Is a rhombus a square?
Sometimes.
Sometimes. Good. So let's put that together in something we call the hierarchy. I'm going to bring that down to number 90. So if we need it, it'll be here later because we're going to add to it. All the way to 90. Okay, so at the top of our hierarchy, by the way, do you all know what a hierarchy is? Yeah, can you give me an example of a hierarchy? How's that been, is it? King or queen, right. King or queen is on top, and then below the queen is, we'll do the British monarchy if you prefer. The queen is on top, who's below the queen?
The children.
No, the king's off, the king doesn't really matter, he's just kind of like he's just like a trophy husband in England. He doesn't really have any power. Princess or prince, in this case it would be, what's his name?
Harry.
No,
Prince Edward, another kid.
the guy that gave up his title because he got divorced, and Harry's dad. What is his name?
Some other guy.
Yeah, some other guy, thanks, that's what he goes, that's what it says on his driver's license. Prince some other guy. Why can't I think of that guy's name? Prince Charles, thank you. Good. You guys are a lot of help. Thanks. So below the queen is the prince, below the prince is the, I don't know, who's after a prince? A jester, right. Forget about the dukes and the earls and everybody else that goes right to jester. So the guy in the funny hat is the 3rd guy in charge in the country. And then all the way down to the peons down at the bottom, which have to do all the hard work. Other examples of hierarchies.
The caste system.
Do tell.
I don't know what the places are.
I understand.
Rhombus
Yeah.
and then there are other people.
The priests.
Something else?
Something else, something else, right? I heard priest, right?
Yeah.
Yep. Catholic Church has a hierarchy. At the top of the Catholic Church is the Pope, and then,
Priests.
no, priests are wait, who's next? Bishops or cardinals? I never remember.
Cardinals.
Cardinals, bishops,
Something else.
Me.
yeah. Then Emmett, then priests and deacons and
first.
Altar boys and girls and parishioners.
People that come to church.
Yeah, parishioners. Anything else? How about the food chain? Who's at the top of the food chain? Humans. Sharks would also. You heard that, right?
That was
Okay, cool. All right, so let's do the hierarchy for quadrilaterals. At the top is a quadrilateral. From the quadrilateral, we get a parallelogram. And we have three others to add to this. The square, the rhombus, and the rectangle. The question is, where do they go? Rectangle next, where? Right below?
yes.
You think so?
Oh.
Yes?
It has to be like rectangle, square, rhombus, because they all come from one. Right?
I don't know. You're saying here, like rectangle,
Oh, got it.
rectangle, and then, where'd you say square was?
Oh, just one second.
Oh, wait, he's having a pencil issue.
The square would just go right down the middle, and then the other one would go to the side.
Whoops.
No.
Oh, it's a person.
Is that right?
Is that right?
I don't know.
I
I mean, they're all parallelograms, right?
That's true.
So they would all.
What do you
go
got?
in the parallels.
It's like the two make it like a branch together and then go down and it's a rectangle or it's a square. Like a. Can I just show you?
I know. I think mine's right.
It's right on the board.
How do I erase?
How do you erase?
Yeah.
You click on the little circle over there, right here. Click on that little circle. Yeah. No, not with your finger. Your finger isn't that. There you go.
How fun for you.
Yeah. Then click on the black.
This.
Yeah.
Good job on getting that.
Alright, so I was gonna go like that, and then they make a square. Not a good square, but.
No, how about we erase that and write the word square, because that looks nothing like a square.
Yeah, I think mine's right still.
Okay, thank you. All right, so Emmett, you're arguing yours is correct.
Yeah.
If yours was correct, which it isn't, but if it was, that would mean, if we included this segment down the middle, that would mean that we would have squares that are parallelograms but aren't rectangles and rhombuses. Whatever. Rhombuses. So that's correct. Now, what does this mean? It's everything that's above it. In other words, a square has to be a rhombus. It has to be a parallelogram. It has to be a quadrilateral. It has to be a rectangle, a parallelogram, quadrilateral. It could be things below it, but only if it's that thing below. In other words, a rhombus can be a square only if it's a square, which doesn't make a lot of sense. Okay. We go from general up on top, to specific on the bottom. Specific. Which not all hierarchies do that. In fact, most of them do the opposite. They go from specific to general. So you go from one pope to a whole bunch of parishioners versus us going from a quadrilateral, which is pretty general, down to very specific. Yes, sir?
So if you're going from like rectangle to like square, that would be like a never, right?
Rectangle to square is sometimes. A rectangle is a square sometimes. When is it sometimes? Only when it's also a square. It gets a little weird. Right. Okay, which doesn't necessarily, well, I guess it could apply the dog analogy. All golden retrievers are dogs, but not all. I gotta think about that. Because then you get like mixed breeds. You know, when is a poodle also a Pekingese? Only when it's a peekapoo. that kind of thing, which sounds like a Pokemon. Question?
You could say that, or could you say that a parallelogram is a rhombus if it's a square?
Yes, because once the figure is a square, it's everything. With what we've talked about so far. We're gonna add more to this hierarchy later, that's why I threw it over on 90 so that we can come back to it tomorrow when we talk about the last two shapes. Okay? The difficulty for you is going to be remembering all these properties that we've talked about. It's going to happen in two examples. It's going to be, here's a square, go and solve a bunch of stuff about it, so you have to remember all the facts that are true about a square so that you can solve it. Or, here's a general shape, which shape is it? Is it a square, is it a rectangle, is it a rhombus, is it just a parallelogram, or even just a quadrilateral? That's going to be a little tricky. And I have a couple days worked in here to help you review that. Once we have all the quadrilaterals covered and ready to go, I've got a bunch of worksheets that'll help you recognize which quadrilaterals are which quadrilaterals. And then, of course, the always, sometimes, never is going to be present here quite a bit when we're working with quadrilaterals. Okay? Question?
Can you go back to the rectangle one? What's the relationship between like angle A and then like angle R but the right side of it?
Could you be more specific? There's 4 angles at A.
Where A is, like that angle right there.
This angle,
Yeah.
okay?
And then the R but like the right side of the line.
This.
Yeah. Like what's the relationship?
To answer that question, I'm going to ask you another question. What kind of triangle is RAE?
Isosceles?
Does that answer your question then? These two angles are congruent.
Okay.
Okay, so it's the old isosceles triangle problem. Here's the vertex angle, how big are the base angles, or here's the base angle, how big is the other base angle and the vertex angle.
Okay.
Okay, we good? Questions? Beautiful. Let me